Okey, sanırım yayındayız. Şimdi bir resetleyeyim. Bir yandan kayıt da almak istiyorum ki şey olsun. Bunun sonra bir kısmını şey olarak export alabileyim, repurpose edip başka bir şey için kullanabileyim diye. Çünkü ufak bir demo yapacağım. Onun için bir şey açacağım. Dur, nerede o? Screen flow. Screen flow. Açalım. Seni bir Seni bir yeni doküman yapacağım. Olur. Şöyle el altında dursun. 1080p 1920'ye 1080. New recording diyeceğim. New doküman değil, pardon. OBS but tiny virtual camera, stream camera. Bunu kaydedecek, mikrofonu kaydedecek. Bir de nerede benim diğer monitör? Ana. Diğer monitör görmüyor. Mikrofon. Interesting. Sadece bu monitörü mü görüyor bu? Kaldırayım mesela bunu. Diğer desktop'u algılamıyor. Okey. O zaman şöyle bir şey yapacağım. Bum. Buradaki seni full screen'den çıkaracağım. Sonra hop sürükleyeceğim. Başka bir desktop'a atacağım. Buradan o desktop'u paylaşacağım. Bunu paylaşmayacağım. Nerede o? FHD. Seni paylaşacağım. Picture in picture. Start. Çok kocaman oldun. Biliyor muyum seni ya? Ayarlarız, dur bakalım. Bu değil. Picture in Picture'da title bar'ı falan gösterirse küçültebilirim bunu herhalde. Tamam, şöyle drag edebiliyorum. Tamam, böyle elimizde bir workspace var. Burayı kaydedecek. Kaydedebiliyor mu? Ekle bakalım. Nasıl? Diğer monitörün adı yok, sadece görüyor. Neyse, bunu eklesin. Bunu kaydediyor. Buradan da bakabiliyorum, nasıl olsa buraya gelip görebiliyorum. Süper, el altında. Ya da bunu kapatayım, bunu şey yapayım. Şurayı kaydetsin. Buradaki şey tekrar Diğer monitörü alacağım çünkü bir yandan stream'de olan biteni de görmek istiyorum. Alttaki ekstra monitörü feda etmek istemedim. Şimdi şunu kapatacağım. Kapağın. Nerede? Better display. Generic display değil. FHD değil. Generic display bu. Bunda picture in picture yapacağım. Start. Kapat. Tamam, süper. Elimde kaydedebileceğim bir monitör var. Mikrofonu falan da kaydediyor. Buradan ufak bir demo kaydı yapabilirim yani. Okey, bir süre İngilizce bir kayıt yapacağım. Yani buralardaysanız chatten soru falan da sorabilirsiniz isterseniz. İstemezseniz zaten kayıt amaçlı bu. Ondan sonra yayına kaldığım yerden devam edeceğim. Sadece işte bu aradaki şey çıksın, bu kayıt işi aradan çıksın diye. Bir tekrar kontrol ediyorum. Hatta bir dry run yapayım ya. Şunu bir kaydet. Şimdi bunu kaydetmeye çalışacak. Ve sonradan çıktığı sonuca bakacağım. Okay, I'll just have a sample recording so that I can check, whether it's recording my camera and everything else. When it's done, I'll start the actual one. Let me stop this one. Kapattım. Kontrol T miydi bu? Tamam, bakalım şimdi. Kamera var. Ekranı da kaydetmiş. Kamerayı kafama göre oynatabiliyorum. Süper, harika. Bu kayıt, bu sistem çalışıyor. Bunu kaydetmeyeceğim şimdi. Mikrofon kaydı da almış zaten. En kötü tekrar bir daha yaparım. Çok da sorun değil. Nerede şu? Tekrar record deyince aynı kayıt, aynı settinglerle kaydet. Bir daha configure edeyim, ne olur ne olmaz ya. Tamam. Okey, bu dursun. Bunu, süper. Ben bu kaydı alırken arka planda müzik olması sorun değil. Sadece mikrofon çıktısını kaydediyorum o ekranda. Şu an kayıt alıyor zaten. Bir şeye bakacağım yalnız. Tamam. Hey everyone. Başa al tekrar. Dur bakalım. Hey everyone. I'd like to... Nasıl başlasak ya buna? Bolos başlayacağız. Nasıl başlayacağız? Bir açayım önden. El altında olsun. En azından hani kafamda bir şeyler olur. Spike.is. Hello everyone. Today I want to introduce you a new project called Spike, Secure Production Identity for Key Okay, I'm taking it over, and I'll cut it out anyway eventually, so I just want to get used to the flow. Hello everyone. Today I want to introduce you a new project under Spiffy umbrella, Spike, which stands for Secure Production Identity for Key Encryption. It's hard to say. Okay, I'll do it once more. Hello everyone. Hello everyone. Today I'd like to introduce you a new project called Spike. Spike is a project under SPIFFE umbrella, and it stands for Secure Production Identity for Key Encryption, which is Spike. It's a secret store that uses SPIFFE as its identity control plane. Today I go through its documentation, its repository, and I want to like set up everything from scratch, and also like go through the quick start guide and see together how it works, what we can do about it, and how its future will pan out. So this is the website of Spike. It's spike.ist, like a spikeist, I don't know, however you call it. So it has the site is pretty new, so it's under development, but still there are certain things that you can go and see. Like there's a kind of an overall system overview, system diagram, what kind of components it has, and also there is a quick start guide about telling you about how you can start experimenting with Spike. As you see, it's still there are missing bits and pieces. The project is pretty new. I just created the public repository today. The repository was private for the last couple of weeks because like we were discussing where to put it, how to launch it, and now it's under SPIFFE GitHub organization. Let me open this one as well. The URL for the repository is SPIFFE github.com SPIFFE Spike, and let me see. And like it's a alpha release project as per the notice implies. So what in short is Spike, you might ask me. It is Spike is a SPIFFE enabled secret store, and we are trying to align how it behaves to other well-known secret stores like HashiCorp Vault, for example. So it has a key value interface that acts more like how you would use a Hashi Vault user experience. The reason we do this is because like initially not to create friction, because you will be as a user more familiar and more comfortable with a API or with an interface that you know and you know how to use. So it uses a similar CLI, but behind the scenes it's different. It's using SPIFFE as its identity control plane, which makes it relatively more secure. So I'll show it with a demo and it will be more clear, I guess. Let me just quickly go through the website and also maybe the source code, and then I can dive into the demo. So the website has like we are publishing our changelog, what we have done so far. This is the like really early release version 0.1.0 that has certain interfaces like put, read, delete, undelete, and list. So you can list secrets, create, delete version secrets, and things like that. Later down the line, we are planning a metadata API, so you can query, secrets, expiry times, other meta information, version information, and things like that. But it's not there so far. So there are ways to configure Spike. It's in the documentation. Again, we are going to add more configuration options, but how the configuration is done is typically through environment variables, so that it can be more portable to be used. So essentially, Spike doesn't assume any kind of like environment. It's not dependent on Kubernetes. It's not dependent on a operating system. As long as there is SPIFFE support, it can run anywhere, including Linux, Windows, and other places, and including Kubernetes as well. And to make the configuration also like a global, we are using environment variables, because environment variables are supported almost everywhere. It's easy to configure and it's easier to relatively easy to manage. So that's one of the decisions that we have made. And as the topic of decisions, we have what we call architectural decision records. So whatever we decide, we keep a detailed discussion records about it. So why we choose that way, what we are doing, and this is all open source. So you can feel free to contribute to it, add value to the discussion. And like these records are just historical records. They are not set in stone. For example, a while ago we decided to use Postgres as a backing store, and then we realized an S3 Amazon S3 or like a Minayo compatible storage would serve at least our initial needs much better. So we superseded that one with another architectural decision record. So like things are in progress, and we are transparently sharing everything that we can, including designs, flowcharts, diagrams, like for example like how secrets are exchanged, how the system is initialized, and everything. But yeah, that's the project so far. Let me go through this quick start tutorial. It will be easier to use it like when you get your hands dirty, I guess. So I'll follow. So to use Spike, you need Spire or something SPIFFE compatible. We'll be using Spire, and to use Spire, like you need to one way to do it is to build it from the source. Or you can download the binaries, or if you are in a orchestrator like Kubernetes, you can just use Helm charts and deploy Spire through Helm charts. But since this is a Linux machine, the way that we can use Spire in this one is to just build it from the source code. So I'll just follow these instructions to see how it is done. But I have already Spire installed on my system, so I'm not going to copy the binaries to where they are supposed to be. I'll just create a temp folder, and then just go through the creation process rather than moving them to something under the path. So where am I? Let me check first. Let me create a temp folder, cd temp, and then I'll follow the instructions in the guide, and I'll just clone Spire and cd into Spire. And like if you have make, building Spire is just a single step. You do a make build, and it will create a Spire server and a Spire agent binary for you. I'll just wait for it to finish. Okay, so it's created Spire server, Spire agent, and Spire OIDC discovery provider. So if I do ll bin, I'll see like all of these binaries. So if I do a bin Spire agent, it will give me like an API about how I can use Spire agent. So I have Spire in my system, and let me open the repository as well. This is the I have lots of stuff open. Let me close them all first. So this is, let me collapse a bunch of more. This is a Spike repository, and it has a config folder down here, and it has sample Spire server and agent configurations here, and the scripts down here, the scripts under this hack folder uses those configuration to initialize itself. So we have a Spire agent starter and Spire server starter that uses those configuration files to bootstrap. I can just quickly go through them, and these configurations are just for like development purposes. If you want to do a production grade Spire deployment, then I highly encourage you to go through the official SPIFFE documentation. You can go and see it at spiffy.io. From spiffy.io, you can go to like Spire or maybe documentation, and then there is like configuration reference and scaling references and how you can install things, how you can configure stuff. So I suggest you go through those, and also jump into the Spiffy Slack channel to ask your questions, essentially, because there are in the Spiffy Slack there are subject matter experts that can help you, and then you get to go to the Spiffy Slack. Like, there is this Slack button down here, you can just click it. It's a public Slack channel, so you can get help, but essentially don't the moral of the story is, don't consider this as a production setup. It's far from it. Like, it has dummy certificates and dummy configuration to just make a spiffy Spire setup running, but that's it. Not much. So let me go through the configurations quickly. This is the agent configuration. It's using a dummy certificate that we have on the folder, and it has a trust domain spike ist, and all of the IDs that we create, all of the identities that the workloads use are dependent on this spike ist trust domain. So we assume in this demo the entire machine as a single trust boundary, and the trust boundary is identified by this domain. I'm not diving into too much spiffy details, but a trust domain in a sense is an enclosure. Like, it doesn't have to be a DNS, so this looks like a DNS entry, but it can be anything. Like, it can be, I don't know, it can be like my production organization or something like that. So it doesn't have to be like a DNS, but typically like in the Spiffy and Spire examples that I have seen so far, it is preferred to be used as a domain because it's easier to relate in that case. This is the agent configuration, and this one is the server configuration. Let's see. It has the same trust domain so that those two can talk to each other, and we are using a join token to let the agent trust the server and vice versa. There are different ways to establish this trust between server and agent, and this join token is more for demo purposes. Again, I highly recommend you to go to spiffy.io and read different ways to establish this trust attestation, but in our demo, using a join token is good enough. Yeah, and that's that one, I guess. Again, we are using these dummy certificates as a upstream authority initialization, and that's more or less how the agent is configured. I have two starter scripts. I want to go through them to show you, what's going on. Then I'll run them. So this is the server starter script. So what it does is, if there are anything from the former batch, we delete them, like the agent join token and admin token. Then we build the binaries, the spike binaries, which I'll tell about them shortly. Let me show it. So we have. Let me show you. We have a keeper, nexus, and spike as binaries, and these lines that you see below are creating those same binaries in various different architectures. But for the sake of our work, we'll be using these three. So the nexus, spike, and keeper establish the spike system. So the server starter script builds those binaries from scratch as well to make sure that we are using whatever the source code, you know, maps. Let me see. So what do these do? So we have Nexus. Nexus is like, you can think of Nexus as the secret store. So if you are familiar to HashiCorp Vault, Nexus is considered as the vault where the secrets are. Keeper and Nexus talk to each other, and they exchange trust materials using MTLS. So Keeper, Nexus sends its root key to Keeper, and Keeper keeps it in memory. So what use this could have? For example, if Nexus crashes, then it can ask Keeper to give its root key back. And since this connection between Nexus and Keeper is done through mutual TLS, it is like relatively secure, which means as long as we can trust how we identify and how we uniquely and cryptographically verify that these binaries are the binaries that they claim to be, then they can securely share the root key through MTLS, and like Nexus can use Keeper as a backup medium in that case. But how do we trust those essentially? To trust those, we use SPIFFE IDs. What are SPIFFE IDs? So for that, I am going to show start Spire. There should be a registration script somewhere. It's here. So SPIFFE IDs are a way to cryptographically attest a binary or a workload that it is the workload that we trust. There are various ways to attest it. In a Linux environment, we can query the kernel off cycle out of band to attest the authenticity of a workload. So for example, here we are making sure that our binary, to be able to get an ID, has to have a certain SHA hash, has to be under a certain Unix path, and it has to be run by a certain ID, a user ID. And there are other selectors that you can add, and if you add enough of these selectors, then the premise is you can cryptographically verify that this is the thing that you are using. Because assume if there's a hacker that wants to like deploy their own counterfeit workload, then the SHA hash will not match because it will be a different binary. Then we won't assign a SPIFFE ID to it, and therefore it won't get a certificate, and therefore it won't be able to establish the MTLS connection that I have been describing. And this provides a robust security between the store and whoever is talking to the store by leveraging SPIFFE as the identity plane. So that's that one. Let me go back to the server starter. So what we did is we built Spike from the source, and then next is we cleared whatever extra tokens and join tokens and things that we had. And the next is starting the Spire server. And start Spire server is, let me show you, it's like a one-liner. We are running the Spire server with this configuration. Agent starter does similar things. We generate an agent token. Let me show that one as well. Generate agent token. So we use Spire server to create a token for us, and the way that we do that this agent token or the bootstrap token initialization is done is you provide the token file to the agent off cycle out of band, and that's how the agent and server can trust each other, because as an administrator, I know the server, I know the agent, and I am asking the server to create a token, and I am inputting that token to the agent, which means as long as I am trustworthy, then the agent and server are trustworthy by the linkage of this token file. This is one of the ways that is done. Like I said, there are other ways to do it as well. You can use cloud identification like AWS IAM. You can use Kubernetes projected service account tokens. There are many other ways to do it. This is the easiest to do it in a demo environment, and that's why I am choosing to follow this path essentially. So let me go back. Spire agent starter, that's we generate agent token, then we create those identity entries. Register Spire entries script does it. So what we do here is we say for Spire keeper to be authenticatable in this system, it needs to have a certain user ID, it needs to be running under a certain path, and it needs to have a certain SHA hash of the binary. And we do this the same for Nexus and the same for Pilot as well. What is Pilot? Pilot is the binary that you talk to the system. Again, if you think on in the terms of HashiCorp Vault, it's the command line interface that you like interact with your key value store and securely store your secrets and things like that. So those are that one. I think that's good enough of an introduction. You can go and like check out the source code yourself. I can like just briefly go through the folder structure as well, I guess. All of the applications that Spike has is under this app folder in its root. So we have Keeper, Nexus, and Spike. These are the system components. Spike is Spike Pilot, but since the binary's name is Spike, the folder is also named Spike for convenience. Other than that, the documentation that you see on the website, it is defined here. So if you want to add value to the documentation, you can just edit it, suggest improvements, and create pull requests around the documentation as well. Like I said, the documentation is still in its infancy, and it's improving as we speak essentially. Other than that, we have these internal components that all of these Keeper, Nexus, and Pilot use. Later down the line, we have plans to like upgrade some of those internal code to a more reusable external, like a package folder, because some of these algorithms are or some of this functionality is like not just internal to the project, but it can be reusable. For example, this structured logger that we have, it's a good initial starting point for a logger, but there's no reason that it shouldn't be like a standalone logging library that people can contribute to it and like Spike can consume it on the side. So there are certain code pieces that can be made more public, more reusable, and like there are plans to like do that as well. Let me copy this one. I like my headers. Let me paste this one down here as well. So what else do we have in the folder structure? All of these, this is typical Go project. So all of these binaries also have their internal utility methods. So though these internal ones are just used for this module itself, but not shared with the other modules, and the higher level internal is shared between 2-3 separate Spike components. We have the regular like repository files. We have a README. We have a security file that tells you how you can responsibly disclose security incidents if you find one. The project is under Mozilla public license. What else? There is a documentation about how best you can contribute. As a quick summary, I can say the way to contribute to the project is there are several ways. Like one way is you can just email the team or email essentially email us, team@spike.is, and then we can consider and start initiate a discussion. But the best way is to join the Slack community and start a discussion there, because Slack is where the specific community is hanging around. So you can like start a discussion around there, and like if you have a feature idea, if you have a bug, if you are having trouble installing and using Spike, then there will be people to help you in that regard. That's that one. There's this Jira.xml. It's a file that we use for internal task tracking purposes, so that we don't pollute the repository's issue list too much. But feel free to create issues as well in the GitHub. We'll discuss that as the time goes by as well. So you can just go to, let me show you. Yes. You can just come to Spike. There are no issues at the moment. You can create a new issue. There are also no issue templates at the moment, but you are recommended to follow the contributing guidelines, common sense, and specific code of conduct, and you can create an issue here. But I still recommend, before creating an issue, at least initiate a discussion in the Spiffy Slack channel, so that we can be more helpful about how to create and how to track those issues as well. That's that one. And maintainers, right now, Volkan, am the lead architect. Kevin said he would be helping the project as best as he can, but he's like my bus factor backup, essentially. If there's something to be done on the repo and I'm not around, Kevin will be there to help you. This is relatively a tiny project in terms of Spiffy project categorization, and since it starts as tiny, a single maintainer is good enough. But if the project evolves, we can have more core maintainers as well, and also it depends on how much interest and how much support we can get from the community. So feel free to chime in, feel free to add value, and feel free to let this project make the world a more secure place. So that said, let me go to my workspace folder and like start doing a quick demo. I'll go to desktop workspace, where my Spike project is, CD Spike, and I'll pray demo gods that this one works, because it was working last night, but it's live demo, anything can happen. And if things happen, it's fine. We'll be debugging it on live stream, which is also extra fun, essentially. So let me see what I have. I'll list the hack folder, and I'll just follow the steps that we have done so far. So I'll first start the server starter, hack Spire server starter. It will build the binaries and it will initiate a Spire server. Let me split the screen. I will need an agent as well. Hack Spire agent starter. It will do its thing and it will start an agent as well. So I need two components, Spike Nexus and Spike Keeper, so that I can use the secret store. So, and if I search in the project folder, let me extend this a little bit, and let me actually let me move these two down, because server and agent, they'll just chat down below, but it's not, their chatter is useful for debugging purposes, but other than that, it's like typically you can just ignore it, because like Spiffy is something that it's something that you ignore because it works so well that you don't even realize it's working. So that's why I can just, move these two down below and focus on the rest of the spike components. Let me move them to give some screen space. So we have keeper here, nexus here, and spike here, which are all of these are our binaries that we'll be using. So I'll start keeper first. Sorry, I'll start nexus first, and it will say like, hey, I started, I'm listening, and things like that. And it will try to talk to keeper, and there's no keeper here, and keeper is not strictly necessary, so it will try to talk to keeper, it will retry, and if the connection is refused or whatnot, it will still try to establish that connectivity. But even without keeper, you can use nexus. It's just, when the nexus crashes, the secrets will be gone without keeper. Or actually, not the secrets, but the root key will be gone, so you cannot recover the secrets without nexus, at least in this current state. So let me start the keeper as well to have more resiliency in the system. So these two folks will start talking to each other. I'll split this part vertically too, and move this one here. So again, these two can talk to each other. They will chat. I'll just ignore that for now. Our binary is spike. So when I say spike, it will say, hey, this is spike binary. You need to use spike command. So I want to get secrets maybe. Clear spike get tenants. I don't know what tenant, Acme DB. I want to get Acme Corporation's DB username and password. And it says, oh, you haven't initialized spike. Can you please initialize it? By the way, this initialization flow is just for the sake of the demo. The flow will change, but still there will be an initialization flow because I am the first user to have installed Spike. I am a super admin at the moment, and I need to create an initial admin token that can govern this entire system. We have plans to morph this one into different ways to get identities as well, so that you don't have to manually create an admin token. But at least in the initial phases of the project, you'll have to initialize and enter a password and create a admin token for yourself. So I'll do a spike init. Again, right now, for the sake of this demo, it's saving the token on the file system. Later down the line, this won't be in the file system, it will be in memory. But right now it's in the file system, and it is plain text, it's not encrypted, just for the sake of the demo. But like I said, in later phases of the project, this will be in the memory of Spike Nexus, and you can only decrypt it by providing a passphrase. So let's see how the token looks like. Cat Spike admin token. It's like a typical token that starts with Spike and then some secure set of random characters. Again, we have projects to use more common tokens like JAWT tokens and other like OIDC authentication and things like that, but those are all planned out. Like, this is just the first week of the project, and I'm still amazed that we could go this far this quickly. So let's see. We initialized it. So let me clear this one and do the spike get again. No secret found. Okay, let's create one. Spike put, and you might have realized that this interface looks a lot like how you can use a HashiCorp Vault, and it's intentional. Like I said, we want the experience to be common so that you don't have to learn something new just to use a new tool. So I'll do tenants Acme DB username Spike password, I don't know, Spike Cracks, enter. So when I get this one, I can get the password. I can change it when this one as well. Well, for example, I made a typo in this username. It says a double N. So let's change this one. Username. Spike pass. Spike is Arium. So awesome that one S falls out. Okay. Okay, so I need to do put. It's giving me an error. Let's do a put. All right, so let's get it again. We have this one, but we have more. Since we put 2 items to the DB, to the store, we can get an older version. Just let me clear this one. -V. So this is the first version. This is the second version. So we also have versioning in the project, and I can delete versions as well. So if I do spike delete tenants acme db, it will delete, you know, the most recent version, but I can also provide a version to delete. So if I want to delete the first version, it will delete, and if I want to get the first version, it will say secret not found. If I do second version, it will say there's a secret, things like that. What else? Let me do spike again to see what other methods that we have. We demote delete, get, help, you can use it. We did init, we did put. We can undelete as well. Let me do that. So clear. So we deleted recently the version 1. So if I undelete and then spike get, I'll get the secret again. So right now we maintain a certain set of versions. Like we keep at the moment 10 versions by default. So if you create an 11th version of a secret, the oldest one will be permanently deleted. That number is configurable from the environment variable. Let me show you where it is. Quick start configuration. So it is like maximum secret versions to maintain. So you can, it's by default 10. Come on. It's by default 10, but you can change it to whatever you want by setting up a environment variable. And there are additional API endpoints that we are going to implement to totally purge the secret. So I don't want to even keep the versions. I want to destroy the secret completely. And again, this is HashiCorp Vault's the destroy key value method. It is not implemented here yet. It will be. But yeah, we have versioning, we have deletion, we have undeletion, the basic needs for a practical key value secure secret store. And we also have list. If I do a spike list, I see that I have one tenant as a secret, as a path to a secret. And the reason we use paths is, again, we can be able to define policies based on these paths. But that's all for the demo, I guess. Like I said, this is a initial project, and it's really exciting to be fair, because this is the first of its kind that is using SPIFFE as its identity control plane, and it is a first-class citizen to SPIFFE. There are other SPIFFE-related secrets management open source solutions, but they don't assume SPIFFE as they are not this intimate with SPIFFE. They assume other primitives like a Kubernetes secret or like a Kubernetes environment or like certain service accounts and an orchestrator to be able to like run. This is more generic. It can run anywhere, any place in the known universe, as long as that known universe is also supporting Spiffy and Spire. But yeah, as far as this initial demo goes, that's all there is to it that I can share. The project, like I said, the website is spike.ist. You are more than welcome to read it and like contribute to it. On the website, there is this tiny GitHub icon, link, whatever you call it, and you are more than welcome to go to the project and like give us a star. Right now, I am the only star giver. The more you talk about this project, the more you mention it, you add stars, you add comments and suggestions, the better it will be. So all kind of contributions are welcome, as I said. And we have one release at the moment. It is like version 1.0. It's the first version, and we have binaries for like all of the environment, so that you don't have to recompile Spike if you don't need to. But still, I would go through this entire experience and follow this demo myself if I were, to learn Spike and, be a contributor to the Spike project, because like getting your hands dirty is the best way to like get used to a code base. But yeah, that's it. I hope you like it, and I hope you'll be a part of this initiative. And until next time, and until the next demo, keep your secrets secret. Okey, bu kaydı yaptım. Şu şeyi kaldırayım. Nerede? Yanlış yerdeyim ya. Recording'i kapatayım. Bakayım düzgün kaydetti mi? O sahne. Birkaç kişi gelmiş. Nasılsınız? Niye kapanmadın sen ya? Stop recording. Şimdi şunu şöyle kapatabilirim. Tamam, süper. Bunu kaydedeyim, şey yaparım ya. Bunu offline editlerim sonra. Bu kaç? 45 dakikalık bir kayıt olmuş. Tabii bu demoyu 45 dakika yapmayacağım. Biraz arada çok geyik yaptım. O geyik kısımlarını keserim. Falan. Ama güzel oldu bence ya. Okey, şunu bir kaydediyorum ben. Spike Demo 2024 0-11-08 saat 11:02. Kaydet. Ufak bir ara vereceğim. Geliyorum. Müzik devam ediyor. Kendinize iyi bakın. Aslında şey yapayım ya, ben ufak bir ara değil büyük bir ara vereyim. öyle yemeğe vakti de geliyor. Bir yemek yiyeyim, sonra bu demoyu editlerim. Onu stream ederim. İşte stream'de dinler, işte yorum yaparsınız falan, öyle bir şeyler yaparız. Ama umarım yararlı olmuştur. Spike dediğim gibi güzel bir proje. Spike.ist. Gidin takılın ya Spiffy altında. Hani global bir proje. Katkıda bulunursunuz, güzel olur. Tamamdır, şey yapayım. Okey gençler, ben kaçtım. Tekrar yayın açarım belki duruma göre. Kendinize iyi bakın.